Okay, hello everybody. I'm just trying to get the camera set up here. If you can see it, there's a hook mast hanging from the end of my table. Now let's get started. This is Lab 7. This is friction and the inclined plane. Okay. So what I've got here is the setup that you see on the first page of the lab, figure 1. So I've got a hook mast. The hook mast made out of brass, it weighs 50 grams. Okay, you're going to need to know that for the rest of the lab. The hook mass is 50 grams. I've confirmed that. We are using a felt, a wooden block that is, it has wood, smooth wood on one side, and it has felt, like a black felt material on the other side, and it has an eye hook. So for starters, I'm setting it down on this wooden surface. So the two surfaces that are in contact with one another are the metal of this inclined plane and the smooth wood. And if I were to let this go right now, you'd see the brass start to pull the wood block to what is this? It's my left, so it'd be your right looking at the image, I think. Right, it'd be going this direction. Okay, so I'm going to take a 500 gram, 0.5 kilogram, a 500 gram weight, and this has been verified. I didn't need to double check it, and place it on top of the wooden block. So what I'm doing essentially is increasing the normal force of the block with respect to that wooden incline apparatus. So read about, both in the textbook and in the lab, normal force and friction and those types of things before you try and follow everything that I'm going to do here. Okay? Because understanding normal force and the coefficients of both static and kinetic friction are going to be important, because that's what we're doing in the lab. So it'd be a good idea to have an idea of it concept-wise. One of the things that I did before I started recording the video is I measured the mass of this wooden block. Actually, I measured the weight of it with a postage scale. Okay, the weight of it on the postage scale was 4.0 ounces. So by now you should have done unit conversions, and now I'll just give it to you. I did the unit conversion for that, and I ended up with the wooden block being 113.4 grams. Okay, if I add my 500 gram brass weight that is sitting on top of it, the total mass of what is over here on the wooden surface is 613.4 grams. So what I want to do is I want to add weights to this end just to get it started moving. Okay. So right now it is wood on metal. Okay. Just like in the picture, wood on metal. The smooth side of the wood is down, it's not on the felt. Okay, so wood on metal. Okay, and I'm going to add weights to this until I can get this to start moving. Okay, so static friction means what do I have to overcome to get this to start moving? Kinetic friction is it's already moving. Okay. So I would kind of give it a little tap and see if it stays moving, okay? But for right now, we're going to do the column that's static friction force. So I'm slowly going to add weights until I get the system to start moving. So I'm going to start off with 100 grams and see if that gets this to start moving. So I've added 100 grams and no movement yet. Okay, so let's try 200. let's add another 100 grams and see if that gets it to start moving. And it does. So it's somewhere between 100 and 200 grams. Okay, let's add 50. Does 50 get it to start moving? No. Well, let's see here. '50's pretty close. It's still, so there could be some rough spots either on the incline plane or on the underside of the wood. So it does move at 150. So we'll take the 50 off. But it's real close to 150. So if I add 100, if I do 120, $120 doesn't get it to go. So 140. So we're going to call it 150. So 150 grams is the static friction force that gets this to move, but it's 150 of brass weights. You have the hanger itself, that's 50 grams. So 150 of added brass weights plus the 50 of the hook mass itself is going to be 200 grams. So show you what I mean here by giving it a slight tap. If I kind of just touch the back of this so if I just touch the back of it, you can see that that block starts to move. If I back this up just a little bit so you can see it and hold it, okay, hold it steady. The hook mass is above the ground by a few inches, few centimeters, and I let it go. So I have the 50 for the hook mass, I have a 100 gram weight, and I have 20. So 150 plus 20, that's 170. It's stable. If I give it a little tap, then it starts moving. Okay. So we're going to call that one 170 grams. I back it up, it should stay steady, which it does. You know, it's not moving. But if I just give it a little nudge, it continues. So for the FS column on page 2, table 1, the FS column, the static force required to get this moving, we're going to call it 200 grams. And the kinetic, we're going to call 170 grams. Okay. Now, what it asks us to do, if you look on page 3, there's table 2. We're going to increase the normal force. Okay, the normal force is over here at this block. Now, again, we're just looking at the block, the wood in contact with the metal. So wood in contact with the metal, I have my 500 gram mass on the top of it. So if you read the instructions, you have in the column on the far left, that first column, that's the 500 gram mass plus the block. You have that from before. That's already calculated in table 1. So column 1 in table 2 is just that value of the mass of the block plus the 500 grams from table 1. So it's 613.4 grams. So the first line, adding 0, that's what we just did. That's the 200 grams for static and 170 grams for kinetic. Okay. Now what we're going to do, okay, is we're going to increase our weights over here and see what it takes to get it moving on the hook mass. But we're only doing kinetic. Okay, so if you read the last column, okay, so in table 2, the third column, you're just adding this 50 gram mass to the first column. So the third column is just adding column 1 and column 2, and that equals column 3. Okay, so we've got our 50 grams here that we're adding here. Now we're going to add weights and give it a nudge and see if it moves. Give it a nudge, see if it moves, and slowly increase the weight until we find that kinetic force to get it moving. So I'm going to move my block back. So this is in the air a little bit. And I knew from before 170 got it going. So again, the hook mass is 50. I have a 100 gram weight or brass weight attached to it. So we knew that 100 didn't get it moving. And we knew that 170 from before didn't get moving, but we added 50 to the other side. So I'm going to start out at 200 and see if that moves it. So let it go. Actually, it'd be 250 because I have 100, 100, and 50. So I have 250 grams on the hook mass. Give it a little nudge and see if it. So yeah, 250 gets it to move. Does it stay steady? Well, when I let it go, no. So 250 isn't right. So let's take the 100 off, put a 50 on. So the 50 for the hook mass, the 50 that I just put on, plus the 100 that's there, this will be 200. Go back, let go. I let go and it stays steady. Give it a little nudge. and it stays. It stays. So I need to increase the weight beyond 200. Let's try 220. Come over, give it a slight tap. Nope. Let's try 240 because we know 250 gets it to go. Let's try 240. So it's staying still. If I give it a little nudge, 240 gets it to move. Okay. I don't know how well the camera that I have picks this up, but the hook mass is not on the ground yet. If I bring it back and I let go, it stays. And if I give it a slight nudge, that gets it to move. Okay. So I have 240. So 240 grams is when I add 50 grams here. And when I added 0, so the mass added 0, that first line that you're entering, that's from the previous table, which is the 170 grams. So adding 50 here, I need 240 to get the system to move. Okay, so now I'm going to take the 50 off and it says to add 100. So I'm on the third line. So I have 100 grams, set it there. I know I'm going to be higher than 240. I'm going to slide this back. I'm going to take the 40 that I have off, all right? We'll start out at 250. And we'll give it a tap. So it stays stable at 250. So I have two 100 gram weights and the weight of the hook mass. So I'm at 250 on that side. I'm at 100 grams added on this side. It doesn't get it to move consistently. It'll stay still. And if I tap it, it's very close. I think 20 might be over. I think it might only be 10 grams that I need to add. No, it's, yep. So that's the 250. Bring it back. It stays steady. Tap it, it doesn't move. I don't have a 10 kilogram or a 10 gram mass, but if I add the 20 to it, it stays still. And so I'm at 270 and that gets it to move, right? But if I back this up with the 270 on it and let it go, it starts moving on its own. So I think 270 is a little high. Well, there it's staying steady. We'll call it 270. Okay. So now let's increase this to 150. So now we are on we're still on table 2. We're on the fourth line that we're entering. So I'm adding 150 grams here. I have my 270 over there. So I have 270 here. I'm going to add 20 to get to 290. 290, it's stable, it's not moving. $290 it moves if I tap it. Now let's see if it stays stable at 290 when I let go. And it does. So I'm going to call that one 290. Take this 50 away. There's 100. So this is 200 added. So I still have my block, my original 500. So this is adding 200. Okay. And it seems like, you know, adding 20 or 30 grams to that side has been what has been getting it to move. Let's see if it's going down. So I've got 290 on the hook mass right now, giving this a little nudge. That's actually real close. Staying steady. Let's try 300. So take my two 20-gram masses off. Okay. I have two 100-gram masses here plus the 50. That's 250. Here's 300 because I'm adding a 50 gram. Adding the 50 doesn't get it to move. It's still staying steady here. If I give it a slight nudge, yep. So we're going to say 300 grams there. Now I'm going to add 250 to this side. So there's 100. There's 200. Here's 250. If I slide this back and let go, so it's not 300, because I have 300 here now. Let's try 320. Give it a nudge. I'm thinking this one's going to be 320 because if I let it go, it stays steady. And if I give it a little nudge, yep, 320. So adding 250 here, I get an FK of 320. So that completes table 2. So now, dependence of frictional force on surface area. So what we did was we placed the wood block on, you see how right now the wood block is on this wider surface area. If you read what the instructions tell you about whether or not this is dependent upon surface area, we're going to test this by turning this wooden block on its thinner edge. So instead of being on the larger surface area, it's going to be on a thinner edge. Okay. So just like we did before, if you look on the following page, page 4, block on edge, block laying flat, okay? For the block on edge, we already did the block laying flat. So the second line there for the block laying flat, okay, our original setup was that, okay, what you have there. And we determined 200 and 170 were my friction, my static friction force and my kinetic friction force back on table 1 on page 2. So now if we look at table 3 on page 4, the block laying flat, the second line there, okay, that is still my 200 gram and 170 gram. And it says that in the instructions. So let's see how close the results are by now flipping the block on this edge. Okay. For my kinetic, we started out at 200. Was what got it to move. So if I bring this back and let it go, it definitely wants to move at 200. Let's back this down. Oh, I had 250 on it. I'm sorry. So we have 150. Here's 200. And yes, sure enough, it's still getting it to go at 200. Let's put, instead of 200, let's put 190 and see if that gets it to move. So there's 190. I pull back and let go. 190, it stays put. Okay, so the results are the same for the coefficient of static friction. With the block on its edge, it's 200. Now, kinetic, if I give it a tap to get it going, let's try 150 and see if 150 gets the block to move. I let it go with 150, it stays stable. But if I give it a tap at 150, well, that's interesting. At 150, it does get it to move very, very slowly, but you can kind of see it. So that one, instead of 170, that's actually 150. So there you're going to get a percent difference. For the first one, you won't because we got the same results. Okay. If you look at any of the equations for calculating friction, okay, take a look and see if you have any values in there for surface area and determine for yourself whether or not that result makes sense. Okay. So now we're going to look at the same thing, and the same setup, but we're going to look at different materials in contact with one another. So for table 4, okay, we're going to be doing exactly the same thing. So up until now, we had wood, which is our little block here. It's made out of wood. And then our inclined plane, which is made out of metal. So wood on metal is what we've been doing, okay? So on table 4, on page 4, the wood on metal values for static friction and kinetic friction are going to be the same. Okay, it's going to be the 200 grams and 170 grams. Now what we're going to do is we're going to do the same thing, but we're going to do it for the felt. Okay, the felt's on the other side, so I'm just going to flip the block over, put my 500 gram mass on, and I have 150 grams on this, okay, on the hook mass. If I have 150 on it and I let go, it's moving, right? Okay. So at 150, it's moving. Let's try at 100. For static. Move it back, let it go. Okay, it stays still. So let's try 120. Oh, how close am I? Actually, I have a 50 gram hook mass and a 50 gram weight on it. I can stop it and let it go and it stays still. But if I give this a little tap, if you look very closely, you can see the block moving. If I stop it, it stays still. If I give it a nudge, it starts moving. So right now, I'm going to call that for the kinetic. I'm going to call that $100 grams. So it's staying steady right now at 100. So somewhere between, see if it stays steady at 120. Move it a little. So I'm going to call, so at 100 it stays still. At 120, so 120 felt, so I'm on table 4. The second row, felt on metal. The static friction force, Fs, is 120, and the kinetic is 100. So now we're going to do wood on paper. So I have different materials here. I have paper, okay. I have tin. I have cork. I have cardboard. I also have a small little, I don't know, small section of a brick. Okay, so the next one we're going to do is wood on paper. So I'm going to flip the block back over, and I'm looking at it sliding between the wood and the paper. I don't want the paper sliding on the metal. So what I'm going to do is I'm going to get a piece of tape, and I'm going to tape this down. What I want to be looking at is the wood sliding on the paper, not the paper sliding on the incline apparatus, the incline plane, this metal thing. So I'm just going to take a piece of tape, and I'm going to tape down the paper, because I want to be looking at this thing sliding on, and we're still doing the same thing. We're going to use the same setup. We're going to use the same block of wood. We're going to use the same 500 Newton to increase our normal force. And then we're going to compare it to what we have. So as you can see, the block is not moving on the paper at all. Okay. So this is the same 500 Newton setup on the wooden block, which is the 600 and some Newtons combined. So 100 and, oh no, I'm sorry, 100 doesn't get this to move. So let's try 150 and see if 150 gets it to move. I let it go. Nope. 150 doesn't get it to move. Let's see, let's test it for kinetic. Nope, not for kinetic either. So I'm at 150. Let's try 200. And let it go. 200, it's staying steady. Nope, not yet. We're close. Let's try 220. Well, we're very close. It kind of stops and starts a little bit. So if I add 220 to this, it's still staying. Wait a couple seconds, take a look at it, see if it moves at all. It's not. Give it a little nudge. So we have our kinetic. So our kinetic is the 50, 100, 150, 200, 220. So wood on paper, FK, it's the third column, is 220 grams. I slide this back, give it a nudge, that gets it to start moving. Now, if I move it back and I leave it still, it's not moving. I'm going to add another 20 grams and see if that gets it to go. So I'm going to call that 240. So wood on paper, FS is 240, FK is 220. Flip it over, we're going to do felt on paper. Slide it back, let go. Felt on paper, I still have 240. It's not moving, it's staying steady. If I give it a nudge, look at that again. If I bring it back and I let it go, bring it back and let it go, it doesn't move. If I give it a little nudge, little tap, then it goes. So for kinetic felt on paper, it's 240. Slide this back. Not moving. If I add 60 to it, actually, let's just add 50 to it, or I'm sorry, 10 to it. Let's make it 250. So right now, bring it back and see if it stays on its own. No, I'm going to call that 250. So felt on paper, so that's the fourth line down, the fourth row. FS is 250, FK is 240. Now, let's look at the next one is wood on cork. I have a piece of cork here. I'm going to take my piece of paper and I'm going to take it off. And just remember that what's important here is that I'm looking for the sliding to occur not between the felt, or I'm sorry, not between the cork and the metal. I'm looking at between the wood and the cork. So again, I'm going to take a small piece of tape and I'm going to hold the cork down so the cork doesn't want to slide. Same setup, but I'm doing wood. So I'm going to put the wood side down. I'm going to put my 50 gram, or I'm sorry, my 500 gram weight there. And I have not increased the weight on the hook mass. It's 250 grams. The felt, or I'm sorry, the wood on the cork isn't moving. If I give it a little tap, still not moving. Okay, so let's add 20. So this is 270. It's not moving, it's staying still. Give it a little nudge. There. So that is the FK for the wood on cork is 270. Stay still, give it a nudge, and it continues moving. Okay. So it's at 270. Let's add 20 to get it to 290 and see if this thing starts moving. So 290, it's not moving. You look, bring it back, let it go, not moving. So let's take off my two 40-pound weights and let's add another 50. So right now I have 250, add another 50, I'm at 300. So now, if you watch, I slide this back and I let it go. It takes a second, but it goes on its own. So I'm going to call that 300 for the wood on cork. So now we're going to do felt on cork, which is just flipping over my block, put my weight on it, bring this back. So I'm at 300. I let it go, it stays stationary. I'm 300 on my hook mass, including the hook mass. If I give it a little nudge, nope. So let's go to 320 and see if it moves. It stays stationary. Let's give it a tap. Nope. So that's 320. Let's try 340. So I'm at 340. It stays steady. It doesn't move. Give it a nudge. Nope. Still not moving. So I'm at 340. Let's add 50 and try 350. So even at 350, it's not moving even if I tap. Okay. Let's try 400 and see if 400 gets it to move. 400 definitely gets it to move. But I think the 400 so if I let it go, 400, it stays still. You can see this isn't moving. If I give it a little tap, so I'm going to call that my kinetic felt on cork. I'm going to call that 400. Let's move this back to where it's staying still on its own. It's not moving at 400. If we add so I believe 420 is my static. Yep, 420 is my static. So felt on cork, 420 for FS, 400 for FK. Now I'm going to do wood on tin and felt on tin. So here's my piece of tin. So we'll do wood on tin. Flip the block over. So I'm guessing I got to pull most of these weights off because that's a pretty smooth material. So let's start out with let's start out with 100 grams and give it a tap. Not going anywhere. Okay. Let's try 150. 150. Stays still, doesn't move. Try giving it a little nudge. There. It's moving. So let's let it go. Stay still. So I'm going to call it 150 for kinetic. So we'll move it back until it stays still. Let's see if 170 gets it to move. So if I slide it back and let it go, it won't stay on its own. It was staying on its own at 150. But I can't seem to get it to stay on its own at 170. So I'm going to call wood on tin FS 170 and FK 150. Now let's switch to felt on tin, which just is flipping over our block. I have 170. I'm going to slide the block back and I'm going to let go. So I know I have to take weight off. So let's take my 20 grams off and I'm at 150. Let's slide this back. Let go. It wants to move. So it's less than 150. How about 100? I'll slide it back. Let go. It stays still on its own. Give it a tap. Nope, not moving. Like I tap it and it stops. So I'm at 100. I have a 50 and the hook mass is 50. I'm adding 20. So 120. Does it stay still? Yes, it does. I give it a little nudge. There. There you have it. So 120 is my kinetic. So I just need a little bit more to get it going. There's 120. If I put 20 on it, yep. I'm going to call felt on tin. FS is 140. FK is 120. Now we have to look at wood on brick. Okay. So take our piece of tin off. I'm going to take my small piece of brick here. So we're going to do wood on brick. Okay. I'm going to adjust, since that brick is so much higher than everything else, I want my string to be level. So I'm adjusting my string up to get it level. Right now, there's 100 wood on brick. That doesn't want to slide. Okay. Let's try 200. $200, not sliding. And tapping on the block is not getting, I'm looking to have the block move where the block and the brick meet. I don't want the brick to move on my incline plane. Okay. So that's not moving. So that's 200. Let's try 250. That's 250. So that's getting my block to move. Let's try 220. So if I move this back, stays on its own. Give it a little nudge. So 220 gets it to start moving. Let's try 240. Yep. So 240, I believe. Let's double check it. For wood on brick. There's 220. Yep. So wood on brick, FS is 240, FK is 220. Let's take a look at felt on wood. So there's felt on wood. I'm sorry, felt on brick. We already did wood on brick. Wood on brick is 240 FS and 220 FK. So now we're going to do felt on brick. And I have 200. That's not enough to get it moving. So let's try 250. $250 is not enough to get it to move. Let's try 300. There's 300. $300 is not enough. $350. $350. It's holding. $350 is not enough to get kinetic. Let's try 400. That's 400. Still no movement. $450. We're getting closer. We're still not there. Here's 500 grams. $500's not enough. Okay, let's take all of these off. Try 550. This is 550. Here's 600. $650. I think 650 is kinetic. So it's staying still on its own. I give it a little tap, it moves. Okay. $650. Yep. 650 is your FK. And I'm going to call 670. So we'll go 670 is your FS and 650 is your FK. So that completes, so that's felt on brick. That's the last row. FS was 670, FK was 650. Okay. Now, table 5, you're going to complete table 5 based on all of what we just did and the equations that are on page 2 and the write-up that's on the front end of the lab. So you're going to need to read the front end of the lab, and then you'll be able to do the calculations that are required for table 5. So I'm going to step ahead, and we're going to look at table 6. Now, if you look at table 6, we no longer need I'm going to spin the incline plane around, okay? And I'm going to slowly raise the incline plane to get whatever the object is to move, okay? It's still going to be the block, and I'm still going to have my 500 gram mass. What the instructions tell me to do is to cut off the string. I have my block. I have my 500 gram mass. Now I need to secure the 500 gram mass to the top of the block with tape. Okay. But I don't want this tape to go all the way underneath, because then I'm kind of, my surfaces are, I would have a tape surface and not an all wood surface, okay? So now what I'm looking at is the alternate method. So I'm going to loosen the wing nut, and when the block slides with a constant velocity, okay, I am going to record that angle of incline, and the rest of it we're going to calculate, right? So you're going to write the angle that I measure. You're going to take the tangent of that angle, okay? And then you're going to rewrite your calculated value for UK from table 5 into this third column, all right? And compare your online, you're going to go online and you're going to get online values for this. And then you're going to get percent difference, okay? So wood on metal, metal, wood, spin this around. And I'm going to slowly increase my angle until I get this to move. So I'm going to call that 15 degrees. So for wood on metal, I'm getting 15 degrees. Now notice it's mu sub k, which is the coefficient of kinetic friction. So if you look at the instructions, it tells me to give this thing a slight tap to get it moving, okay? And then the angle at which it moves after I give it a slight tap, I'm going to calculate tan theta and then compare that to the mu sub k values from table 5. I'll give you a hint, they should be close. So that's for table 6. For wood on metal, it's 15 degrees. Now, we're going to do felt. On metal. So I am going to call that 11 degrees. Felt on metal is 11 degrees. Now we're going to do wood. We're going to do it on paper. Take my piece of paper once again. Tape it down. Okay. Same setup. We're going to, let's go 5 degrees. Nope. 7. 10. Nope. About 11 degrees. 12. 13. 14. 15. 16. 17. 18. 18 starts moving on its own. We're going to call that 17. Wood on paper, 17. Now let's do felt on paper. This is a long lab, I got to tell you. I think this is one of the longest ones. Let's go up to 10. Nope. 14. Nope. So I'm at 20. Nothing yet. 22. 23. 23. So 23 degrees is felt on paper. We're going to switch to cork now. I've got my piece of cork. I'm going to jump down to where it's felt on cork since I already have the felt down. So I'm going to skip a line. We'll go up to 22 degrees. Nothing. How about 25? Nope. 28? Nope. 30? Nope. 32? 33? 34? We're getting close. Here's 35. 37? Whoop. Let's try 36. Go down to 35. 35. So felt on cork, I'm skipping a line. I'm going down to felt on cork. That's 35 degrees for felt on cork. Now I'm going to flip it over and do the wood on cork. The good news is I don't think the calculations are so bad on this one. So let's start at 25. 25 might be it. 23. No, 23 it moves. Let's try 22. 22 it doesn't. 23, yes. So for wood on cork, it's 23 degrees. For felt on cork, it's 35 degrees. Now we got to do tin and brick, okay? I'll get my piece of tin, put it down, hold it in place. Wood on tin. Start off at 12. I'm going to call felt, I'm calling wood on tin 11 degrees. So it's 11 degrees for wood on tin. Let's go to the felt side. So looks like 12 degrees. Felt on tin, 12 degrees. So now we're going to do brick. We're going to do wood on brick. So I'm looking at where I don't want the brick to move on my incline apparatus. Duct tape. There are two engineering solutions, duct tape and WD-40. If it moves and it's not supposed to, duct tape. If it's supposed to move and it doesn't, WD-40. Now you're an engineer. Okay. So I am going to duct tape down my brick so it stays in place for some pretty steep angles. Wood on brick. I'm worried about where the wood starts sliding against the brick. So let's see here. So it's somewhere around 18 degrees. Maybe 20? 20. Yep. Wood on brick is 20 degrees. Last one. Felt on brick. So that's 30 degrees. 33. 35. 36. 37. 38, 39, so I'm going to call it 40. I am going to call it 40 degrees. Okay. So you have questions to answer for pages 6 through 10. But that is all of the data collection for friction in the inclined plane, lab number 7. I believe this is one of the longest labs of the semester. So hopefully it wasn't too painful. And so that's the end. So that's lab 7. Stay tuned for lab 8. Have a great day. Have a great weekend. We'll talk to you soon in class. Thank you.